So far, we've discussed mainly the domain of logic, which is prescriptively how do you solve these types of inferences. But of course, this is a psychology class, so we're interested in how does the human mind approach, understand, represent, and try to solve these kind of problems. And this is the domain of deductive reasoning and the study of deductive reasoning. Now, generally speaking, there are two broad theories, at least historically, that have addressed the question of how does the human mind in general approach these type of problems. One theory is typically referred to as mental rules, although I have to say it's a bit of an umbrella term, and there are different flavors of this theory associated with different scientists. But the basic idea underlying this theory is that human reasoning makes use of mental representations that are propositional in nature, almost language-like. Now, to be clear, I'm not suggesting that we have in our mind, English or Chinese or Spanish or Italian sentences, but that the structure of thought, the structure of these representations is propositional and syntax-like in a way that might be similar to natural language. Just to give you an example, then the theory says that as you read a premise, for example, say that you read, if it rains, then I take an umbrella. In your mind, you're representing the logic form of this argument. So in your mind, what you're actually representing is something like if P then Q, that kind of representation. And the theory then says that the way in which you solve the problem is by manipulating these representations using the rules of inference. And these are sort of mental rules that we intuitively possess and that resemble somewhat the rules of logic. Okay. And I'll give you an example in just a moment to clarify this. So the idea is as we read something, we first represent it by really highlighting and representing in this propositional manner the form of an argument, the logic form of an argument, and then we manipulate the premises to try to derive a conclusion. You can almost think of it as if you were trying to make a mathematical proof. You have the premises, can you manipulate them using the rules of logic in order to derive the conclusion? And if you can derive the conclusion from the stated premises using the rules of logic, then the argument is valid. If instead you cannot quite manipulate the premises using the rules of logic in order to derive the conclusion, then the argument is said to be invalid. And generally, this theory also says or proposes that what makes something easy or hard is mainly two things. First, do you have a rule for it? Do you have a rule that allows you to solve a certain problem? And second, how many rules does it take to solve a problem? So if you don't have a rule for something, it'll probably be very hard to solve because you will have to combine in some clever way many other rules. And I'll give you an example of just that in a moment. Okay, let me make this a little sort of more concrete. Say that you have a modus ponens inference. The idea under this theory is that as you read it, for example, you read these two premises, if A or B, then C, premise number 2, B. In your mind, what you're doing is you're somehow representing the logic form of the argument. And I'm not saying that it is exactly this way, an A or B and then an arrow C, but that's just the nature, or sort of that gives you a flavor for what it might, for the kind of representation that we're thinking. A propositional and a language-like, a syntax-like type representation. Okay, so you read the two premises, in your mind you represent them, representing in particular the logic form of the argument. And then what you do is you try to see if you can derive the conclusion by applying the rules of logic. Now in this case, it takes two rules. So here we have our two premises, A or B, then C and B. Well, first, you can use a disjunction introduction, meaning If B is true, then A or B also has to be true, right? If I can have a sandwich is true, then it is also true that I can either have a sandwich or a burger. Right? You already know that one of the two parts of that disjunction is true because premise number 2 says that B is true. So if B is true, we also know, using the rule of disjunction introduction, that A or B is also true. Now, if you know that A or B is true, what do you also know? Well, thanks to premise 1, you can use a modus ponens to conclude that if A or B is true, then C has to be true. So by applying the rule of modus ponens, we've derived the conclusion. So this argument is valid. And if you're wondering whether you will have to perform these kind of proofs for this class, don't worry, you don't. You just have to understand them. Okay, let's do a modus tollens. So that was pretty easy, right? So let's see what happens with a modus tollens. So we start in a similar fashion. We read the premises. If A or B, then C. Second premise, not C. The question is, can I derive the conclusion, which is not A or B? So neither A nor B. So here we are, and we represent it in some kind of propositional fashion. And then you look at it, and you're kind of stuck. You can't really do anything. I don't have a rule for doing anything here. So the idea is that in our mind, we do something like this. We say, well, I can't apply any straightforward rule. So let me entertain a supposition. Let me just assume or suppose that A or B were true. Let's just assume. Let's just say that there's another premise, okay, that I'm supposing right here. Let's just say that A or B is true. If A or B is true, what must follow? Well, by modus ponens, it must be the case that C is true, right? That's what the first premise tells me. So if I can assume that A or B is true, then C also has to be true. But look at what happened. Having made this assumption, this supposition, I've concluded C. So I've concluded that C must be true. But premise number 2 tells me that C can't be true. So I've reached a contradiction. Because at the same time, I'm saying that C is true, thanks to my modus ponens, and I'm saying that C is not true, thanks to premise number 2. So I've reached a contradiction. Now, if something leads you to a contradiction, then the only thing you can do by so-called reductio ad absurdum is to assume that your supposition was false, or rather to declare that your supposition must have been false. So the only conclusion I can make is that A or B cannot be true, which is exactly my conclusion. Why cannot A or B be true? Well, it can't be true because if it were true, if it were true, C would have to be true, but we know that C can't be true. Therefore, A or B cannot be true, which is my conclusion. Remember, we've already gone over this while we were looking at modus tollens a few slides ago. Now, the second theory is known as mental models, and this is a radically different theory. Rather than representations being language-like, as mental rules says, under mental models, the representations that you make in your own mind as you read deduction are more diagrammatic in natures. Let me explain. In fact, this view is based on the Scottish psychologist Kenneth Craig, who thought that the ultimate output of your perceptual process is really the construction of a small-scale mental model of reality. So a model of reality inside your own mind. And that then we use this model to represent the world, obviously, to anticipate events and to reason. So in this sense, a mental model is the ultimate product of your perception. Remember, we've been talking about perception throughout this whole class. Information comes in and we kind of represent it in our mind and kind of rebuild it in our mind. All that this theory is saying is that when you read information, you kind of create in your mind possible scenarios, mental models, that are consistent with the premises that you've read. Okay? So in a sense, this is really just nothing but an extension of your process of perception. You perceive the world and ultimately you create these mental representations in your mind. Mental models says that in order to reason, what we do is we make use of these mental representations. So you read the premises of an argument, and what you do is you construct a mental model of all the possibilities that are compatible with the premises. And here I also sort of, the mental models, you should keep in mind, are really an internal representation, but they kind of really look like and somehow correspond to the world out there. I'll give you an example of this in just a slide. And then what you do is you use these mental models that you've created to evaluate whether an argument is valid or invalid. Specifically, if the conclusion of an argument is inconsistent with any of the models you've generated, then the argument has to be invalid. If instead the conclusion of an argument is consistent with every possible model that can be generated from the premises, then the argument is valid. Again, let me give you an example which will make this a little more concrete. Say that you have the following argument. All of the artists are beekeepers. Some of the beekeepers are clever. Does it follow that all artists are clever? Now, under mental models, you're not creating, these if P then Q, or these, all A's are B's. That's not how it works. According to mental models, in order to reason, you do exactly the same thing that you do with any other aspect of perception. So for example, you read the first sentence, the first premise. All of the artists are beekeepers, and in your mind, you literally picture something that looks like a bunch of beekeepers, and here are the little hats, and you say, okay, so some of these, there also are artists, and it so happens that the artists, all of them are beekeepers. And the reason I'm using this particular picture is because in one of the original experiments, one of the participants who had this problem actually said, I was imagining all these little beekeeper hats, and then I put on top of those hats little signs to say which, who was also an artist. So this is what we mean by a mental model that is analogous to the contents of what we're discussing. You create some kind of mental model, typically visuospatial in nature, and it kind of holds the properties of whatever we're discussing. So in this case, in your model, there are beekeepers and there are artists, and you're connecting them. Okay, so that's how you're representing that first premise. Then you read the second premise that says, well, okay, some of the beekeepers are clever. And I think, okay, so let me see, how many models can I generate from this? And they say, okay, well, it could be, so we got our beekeepers, all of the artists are also beekeepers. So, there's some beekeepers have the little brush on them to say that they're artists. And well, it could be that, look, these three beekeepers right here are clever, but it could also be that all the clever ones are the beekeepers that are not also artists. On the other hand, it could also be that all the clever people happen to be the same beekeepers that also happen to be artists, right? So using those two premises, I've generated these three different models of how the world could be given these premises. And now the question is does the conclusion hold in all of my models? And it's very clear. So the conclusion says, are all artists clever? Well, here in this model, yeah, absolutely, right? This model is consistent with the premises and the conclusion. The conclusion holds in it because the clever people are the exact same beekeepers that also happen to be artists. However, the conclusion, are all artists clever, does not hold in this model nor in that model. And because the conclusion does not hold in all of the models that are compatible with the premises, this argument has to be false. So, of course, this is sort of a simplistic representation, in fact, of both theories. But you can understand from this how profoundly different they are. Mental rules is a very formal approach, literally viewing individuals as, close to sort of formal logicians. So where we use, the rules of logic to try to build our way from premises to conclusion. On the other hand, according to mental models, all we do is, just like we always do when we perceive the world, we create sort of these mental representations of what the world might look like. And these mental representations have certain of the properties of the world, just as you see here. And then we use this in order to understand if a conclusion is warranted, if it's true in all the models I can come up with, or if it is not.